This video moves beyond our last video on dividing radicals. In our last video, we were just dividing a monomial by a monomial, basically one radical divided by another radical. When you can see in this example here, we have 3 radicals in the numerator, all being divided by this 1 root of 6 in the denominator. Now to do this, we have to think back of what division actually means when we're looking at it in a fraction like this. All that is basically saying is that each one of these terms on top, so the root of 24 has to be divided by 6, the root of 48 has to be divided by 6, and the negative root of 108 has to be divided by the root of 6 as well. So we have to, probably to make it look a little more visually understanding here, we take each radical and divide it by the root of 6. So we have the root of 24 divided by the root of 6 plus the root of 48 divided by the root of 6 minus the root of 108 divided by the root of 6. So now we have it broken up into 3 separate divisions, and we can now follow just what we learned in our last video about dividing radicals. And if I showed the work of what's actually going on, this first term is actually the square root of 24 divided by 6. The next one is the root of 48 divided by the root of 6. And the last guy, the square root of 108 divided by the root of 6. Remember, these signs in the middle just keep following down to help us. Now we simplify our division statements that we have. We have 24 divided by 6. That's 4, still under a square root. 48 divided by the root of 6. That's 8 under the square root sign. And 108 divided by 6 is actually 18, so we have the root of 18. So now we have this broken down to something that's a lot more simpler to look at. And now we have to just simplify our terms and group any like radicals if we can. The root of 4 simply equals 2. The root of 8, well, I can break that into perfect squares. That's the square root of 4 times 2. The root of 18 is the square root of 9 times 2. So we're going to break these, simplify them up. Out front, I just have a 2. Then the square root of 4 in here equals 2 times the root of 2. In the last radical, the square root of 9 is 3, so it's coming out with a root of 2. We've simplified our radicals, and now we can consider the case where, all right, I got a root 2 here and a root 2 here. This 2 is just going to come down. That's 2. A positive root 2 minus 3 root 2 equals a negative 1 root 2. There is our final answer in this division. 2 minus the root of 2. And again, you could verify this answer, 2 minus the root of 2, with this original question up top, root of 24 plus the root of 48 minus the root of 108 divided by the root of 6. The decimal approximation to that and the decimal approximation to our final answer should be the same if we had simplified and divided this correctly. The next example we're going to look at is the same sort of situation. We have 3 radicals on top, all being divided by this radical on the bottom. The only difference in this situation is that now we have some coefficients in front of the radicals. Everything still remains the same in our work. This just means that every term on top has to be divided by the radical on the bottom. So we can rewrite it as 8 root 18 divided by 2 root 2 minus 10 root 6 divided by 2 root 2 plus the root of 80 divided by 2 root 2. Now we're going to go through and simplify each of these division statements that we have. In the first question, we have 8 divided by 2 here. That simply equals 4. And the square root of 18 divided by the square root of 2 is the root of 9. Minus, look at the coefficients out front on this guy again, 10 divided by 2. That's fine. Root of 6 divided by the root of 2 is the root of 3. And this last division statement is probably one that will cause a little bit of headache for some of us. We're going to take a look and say, well, this root of 80 on top is actually like 1 root 80. Now, if I look at the coefficients out front, 1 divided by 2, well, that's still going to be 1 divided by 2. I can't simplify that. That's a fraction in lowest terms. But I can look at the root of 80 divided by the root of 2. The root of 80 divided by the root of 2 is the root of 40. So now we've simplified everything. The last one still having a fractional coefficient. We have to go through now and just kind of clean up what we've been doing. So we're going to start simplifying these radicals, and we're going to say, well, we have the 4, square root of 9 simply equals 3, minus this term here, I can't simplify anymore. Root of 3 doesn't simplify anymore, so it's going to stay negative 5 root 3. And out the back here, I have the root of 40. I can ignore the 1. I don't need to write that. But I know that the root of 40, if I was to break it down into perfect squares, well, that's 4 times 10, because 4 is a perfect square, all over the root of 2. So we simplified each radical term. And now we're going to go through again and just kind of clean up any calculations we can do. 4 times 3, that's 12. Minus 5 root 3, still can't simplify anything there. And this last guy, we're going to say, well, the root of 4 I know is 2, so this simplifies to 2 root 10 on the top. And on the bottom, I still have that denominator of 2. Examining this, you should be able to pick out that in this last term, 2 divided by 2, well, that equals 1. So this whole term is just the root of 10, because 2 divided by 2, they divide out to 1. And the other terms just stay where they are. 12 minus 5 root 3. Do a quick examination to see if there's anything else that you can actually simplify. Looking at this, 12 is just a number. 5 root 3, we've talked we can't simplify it. And the root of 10, can't break that down or simplify that anymore. Here's the final answer to the simplification of the original question. So again, I should be able to check this decimal approximation here in the green box in my calculator, compare it against the original question up top, and I should be getting the same decimal approximations. A good strategy when you're doing a question on a test assignment or a quiz.